In this programming example, I will show you how to train a language model and embeddings jointly, and then explore the embeddings a little bit in TensorFlow. So in this notebook, we are creating a language model and training it, and it uses embedding layers. And then we are going to explore those embedding layers in TensorFlow. We start with our usual imports, and these two lines related to Google Colab, so you can access the drive. And we are going to use tokenizer that will take each word and make a token out of it. So we are going to train this on a book called Frankenstein. The text of Mary Shelley's Frankenstein can be downloaded from here. Rename the file to be frankenstein.txt and copy to the data directory. Here, this is the input file name. You can change this to your path. To have your path, you can click over here and then go to the drive, click on the directory of your file, and then copy path, then put it here. So we are going to open the file and read the file. Of course, close the file after opening it. We are going to split the file into individual words. So we use this convenience method, text to word sequence, for that. Then we are going to create these training fragments of individual words. So we do that here. And then we are going to invoke this tokenizer that takes each word and convert it to an index. And we also have a special token here for the words out of vocabulary, because we decided we will at most have max words that we are working with. So this max words is 7,500. That's the number of unique words that we will be using. If we then try to use some other word, it's going to be mapped to this special character, or let's say special token for the unknown. That's UNK, unknown. Then the fit on text method will take the text that we have and now create the mapping from each word to an index. This method, fit on texts. And then here we are then creating our X and Y tensors that we are going to use to build and train the model. Here we are now in the training process. Let's have a look at the model, how we built it. It's a sequential model where we are stacking layers on top of each other. We will start with an embedding layer and the output dimension. That is basically the dimensions for the embeddings themselves. This one. The input dimension for the embedding layer is the maximum number of words that we have in our vocabulary. We have our two LSTM, this one and this one, layers. We use return sequences to be true on the first one because we need the second layer to be able to see all the time steps outputs from this layer. But we only need the last time step output for the second LSTM. So that's why we didn't use the sequence to be true here in the second one. Then we have a fully connected layer with ReLU activation function, followed with another connected layer with softmax. And then we use here categorical cross entropy. And as usual, we use the Adam optimizer, and then we print out the information about this model and we start training the model. Of course, we split the data into validation set that is 5% of the total data set. And then you can have a break until this finish after 32 epochs. This will take some time. And now the training has completed with 32 epochs. So now we are going to see if this language model works well. We are going to look at predicting the next word, and we will do it with autoregression to see that it has learned some language structure. We will present a number of words to the word. It will predict a next word, and then we will just take that word and feed it back to the model. And in order to do that in Tensor, we need to use stateful mode. We are going to build identical model to what we just had, but we will declare the LSTM model as stateful to be true, as you can see here. And what that means that once we have done a prediction, they will keep their internal state, so we can then just feed another input to it and it will have the accumulated state from the previous predictions. We have already trained the model here, but this one wouldn't have that knowledge, the internal state. So what we can do, we can take the old model that we have trained, and then we just read all the weights from that into this weights variable. This one here. So again, we can take the old model that we have trained, and then we just read all the weights from this get weights and store it in this weights variable. And then we take this new model, the inference model, and we set the weights, and we can do that assuming that these two models are completely identical in terms of the number of weights they have. The only difference between these two is that this one is declared as stateful while the training model wasn't, the old one. That one we trained previously. So we should now be able to just build the model and initialize it with the weights that we have already trained. This one, weights, we store it in this variable. Now let's look at the autoregression step by step. So we only pick the highest probability as we do the next prediction. We will start with an input sequence. We will do two words, I and so, as the input sequence. Before we call the stateful model, we need to reset the states, as you can see here, because it will retain states from before. So for the first prediction, we want to set states to 0. And we do that by calling reset states. And then the string we have predicted so far is empty, is a null string, because we haven't done any predictions yet. And then this first for loop is where we are going to do the feed these first initial words to the model. We are going through this first words indexed, which is converted to token. We will add I, so to it, and then we do the prediction on I, and then we do another prediction on so. Now we have built up an internal state for this model. And then after that, we can move on to start predicting, so that this Y predict will be what the model has predicted after we feed it both words, I and so. And now we can, for a fixed number of future words, we are going to do predictions with this method, predict. So we are going to do this for predict length is set to 3 here. So we take out the highest probability from the previous prediction, so that gives us the new word index for that we will view as being the prediction. We will convert that to its actual string. So we can then build up the predicted string so we can see what the result was. But we will also use the new word indexed, the encoded version of the word as input to the next time around. So we create the tensor here, only has that new word index. And then we can do another prediction. So we feed that back to the model. So we do that one step at a time. And once we have done that, we have predicted a number of steps into the future, and we just printed out the string of words. We started with I saw, and the model would complete this with the same sky. So clearly we have a language model that is working. But we also want to look at what embeddings it learned. So if you remember this model, the first stage is in the model, the first layer is this embedding layer that encodes each word into a word vector. Let's explore these word vectors a little bit. We will read out the weights for the first layer of the model or the initial layer by using this get weights. For each of these words, we are going to look up what the embedding is, and then we will look up the other words embeddings that are close to that embedding. And we can see how this embedding layer, how it has chosen to place these different words in vector space. So what we do is basically, we go through all the embeddings here in the inner loop, and we compute the distance between the embedding and the other embeddings in our vocabulary. And then after that, we will print out the ones that are closest in vector space. We can see here that the word the is the closest one because it has 0 distance. But also we have like this one with quotes. So apparently the data should have been cleaned like using these quotes, but it makes sense because they are very similar to each other. But we can see also a as a closest one as well. So and for because these are articles, so the model have learned something about the structure of the language. If you can see also the clause to off is off itself, in with, those are prepositions. So what the model seems to have found some kind of structure in language, that these words are similar to each other, so it makes sense to group them together. We haven't really provided information about how a language is built, but just training to predict the next word. It has found this structure in the language itself.